This assessment asks us how many sets of equivalent hydrogens are in the molecule shown. I'm going to redraw the molecule so that I can more easily point to it and circle. Now, when we think about equivalent hydrogens, let's start by looking at the CH3 on the end. And really what we're asking is if we replaced one of these hydrogens with a chlorine, would we get a new molecule? So let's do that. Let's imagine replacing only that hydrogen with a chlorine, just in this hypothetical example. We would make that molecule. If we replaced this one, we would get a molecule that looked like this. Apologize for the geometry. When I put in the hydrogens, that'll make sense. If we replaced this one here, we would get what would be this one. Now, the way I've drawn them might make them look different, but remember, there's free rotation around these bonds, and how we've drawn it is just my convention, right? It's the way I drew it. All three of these molecules are technically the same. If we were naming them, we might call it 1, 2, 3, 4 chloro pentan 1 amine. We don't need to know nomenclature, but they'd all have the same name, which means they're all the same molecule, which means all of these three hydrogens are equivalent. That is one set of equivalent hydrogens. We won't do this for the rest of them, but what I'll tell you is that if we would get a CH2 as a set of equivalent hydrogens, this CH2 as another set of equivalent hydrogens, this CH2 as a set of equivalent hydrogens, and the NH2 as the fifth set of equivalent hydrogens. Now you might look at this and say, well, hey, wait a second, this is a CH2 and this is a CH2. But if we replaced one of these hydrogens, we would get a chlorine at the 3 carbon. If we replaced one of these hydrogens, we'd get chlorines at the 2 carbon. So these two CH2s are alike in that they're CH2s, but they're not equivalent because this CH2 is closer to the amine than this CH2. So here we have 1, 2, 3, 4, 5 sets of equivalent hydrogens.